Okay, we're now going to get into how we actually conduct a hypothesis test. So we're going to go through the steps and some information, and then we'll go through an example of a hypothesis test with a proportion. So here are our steps. Our first step is to write the null and the alternate hypothesis. So in the last video, we talked about how to do that. The null hypothesis always has an equal to in it, and the alternate has your greater than or less than or does not equal to. Next, you'll select your significance level. Now, in this class, most of the time, this will be given in the problem. And this is known as your alpha value. So depending on the series of type 1 errors. So a type 1 error is when you reject H0 when it's actually true. So if that would be a really serious problem, you would want to use a very low alpha, like 0.01. For less serious cases, you could use alpha as 0.05 or 0.10. But like I said, this will be given to you in the problem. Step 3, we're going to use what's called the p-value method. So your calculator is going to help you find your p-value. So we're going to have a couple of different types of tests, and we'll talk about how to use your calculator to do all of those. So once you've used your calculator to find your p-value, step 4 is to compare that p-value to the alpha that was given in the problem. If the p-value is less than alpha, then we reject the null hypothesis, we reject H0. And if p-value is greater than alpha, then we do not reject H0. Now, here's where you're going to want to look back at the original problem and see if the claim was H0 or H1. So if the claim was the null hypothesis, if the claim had an equal to statement in it, then if H0 is rejected, you'll use the words, there is sufficient evidence to reject the claim, whatever the claim was. If we're not rejecting, we'll say there's not evidence to reject the claim. Now, if your original claim involves an inequality, if it was a less than or a greater than, if H0 is rejected, then we'll say that the null hypothesis, we support it. So we'd use words like there's sufficient evidence to support the claim. If it's not rejected, then H1 is not supported. So we would say words like there is not sufficient evidence to support the claim. Okay, and a little mnemonic device, a little rhyme. So if P is low, the null must go. So this is telling you if P is less than alpha, we reject the null hypothesis. If P is high, the null will fly. So if P is greater than alpha, do not reject. Okay, so now we'll actually get into doing an example. So first we're going to start off by testing a claim about a proportion. So this will be a percentage problem. So one thing to remember, the p-value of a sample is the probability that this sample occurs based on the assumption that the null hypothesis is really true. So we're testing what's the probability that we get these results if the null hypothesis were true. So here's the claim we're going to test. Less than 20% of all workers find their jobs from newspaper ads. Okay, so we've got a less than. We're talking about a proportion. So our alternate is going to be P is less than 0.20, and we want to mark that this is our claim. Remember, our null hypothesis always has an equal to statement, so we're going to say P is equal to 0.2. Okay, so also to remind ourselves, since the claim is our alternate hypothesis H1, we'll either support or fail to support. Another way of saying that is not support. this claim. So if our sample has a low probability, meaning P is less than alpha, then we will reject H0 and support H1. So here's the information that would also be given to you in the problem. To test this claim, we survey a simple random sample of 700 workers, and 16% of them, the sample found their job using newspaper ads. So what we're really asking is, if the true proportion was 20%, what's the probability that a sample would give this 16%? So another way of stating this question, if 20% of all workers really do find their jobs from newspaper ads, then would it be unusual to get a sample of workers in which only 16% or less of them found their jobs in newspaper ads? Okay, so we're going to choose the significance level. We're going to use alpha as 5%. So that's the same as alpha is 0.05. So whenever you're doing a hypothesis test, we're assuming that H0 is correct, that the proportion is 20%. So this is just reminding ourselves again, for our null, we had P was equal to 0.20, P is less than 0.20, and this is our claim. So our sample was 700 workers. That's going to be our N value, how many were taken in the sample. And 16% of the sample found their jobs from newspaper ads. And our alpha is 0.05. Now, in our calculator, we're going to need our X value. And X is the number of people who found their jobs from the newspaper ads. So to do this, we're going to take our proportion times our N value. So this would, the proportion, sorry, this should really be P hat, what was found in the sample. So this would be 0.16 times 700. And this X always has to be a whole number. You can't have a partial number of people finding their job from a newspaper ad. So we'll round it if it's not a whole number. So if we do 0.16 times 700, we get 112 here. So that's our X. Okay, so when you're doing a hypothesis test for a proportion, when you have a P and you're doing a percentage here, we're going to hit the stat button. We're going to use the right arrow to go over to tests. And then we're going to choose number 5, which says 1 prop Z test. So we'll hit enter. And then it's going to ask us for these this information. So P0, or P null, is what we use in H0. So that's our 0.20. So remember, our X is how many people actually did whatever you're talking about. So in this case, found their job using newspaper ads. So we found our X was 112, and our N was how many people were sampled. So that's 700. Okay, now the next part is a little tricky. So you're going to look up at your H0, and so, sorry, your alternate hypothesis, H1, and notice this is what we now called P0. So we want this statement to look just like here, so the less than. So we're going to want the middle one here. And you hit enter on it so that it's highlighted. Okay, and now we'll just go down to calculate, and the good news is it's going to do everything for us. Now the first number it gives us the test statistic, and we're not going to use this, but it's used to find the p-value, and on your homework you might be asked for that test statistic. So we're going to write it down. We're just going to round to 2 decimal places. So here would be negative 2.65, but we're not really going to use that number. The most important number is our p-value. So here we find that it's 0.20. We're going to round to 4 decimal places. 0.0041. And we're going to compare that to alpha. So remember, alpha was 0.05. And this number is smaller than alpha. So P is less than alpha. And remember, so P is low, then null must go. So we're going to reject the null hypothesis. So since the original claim was our alternate hypothesis, we would support the alternate hypothesis. So the sample data supports the claim that less than 20% of all workers find their jobs from newspaper ads. Okay, so we're going to do another example here. So the hypothesis here is that 50% of adults rarely or never fly on airplanes. So since this is a statement, it's not a less than or equal to, this is going to be an equality statement. So our null hypothesis is going to be P is equal to 0.50. We want to remember that that's our claim. And our alternate will be P does not equal 0.50. So in this case, since the claim is H0, we'll either reject or not reject the claim. So we won't be able to actually support it. The best we'll be able to do is not reject it. So our sample proportion will either be greater than 50% or less than 50%. If our sample proportion has a low probability of occurring, then we will reject H0. So we're going to use the p-value method again, just like we did before. So here's our information. So it says, to test the claim, we survey a simple random sample of 1,126 U.S. adults. That's how many we sampled, so that's our N. And 597 of them say that they rarely or never fly. So that's going to be our X value. So we want to know, does our research support the claim that 50% never fly? So first we want to know, just for ourselves, what percent is 597 out of 1,126? So we're going to take 597 over 1,126. And we see that it's about 53%. So we want to know, is this likely if it's really 50%? So we're going to let alpha be 0.10. Okay. So again, to do this in the calculator, we're going to go stat over to tests and choose number 5. Okay, our p-value here, p0 is 0.50. Our x was 597, and our n is 1126. Okay, you can see that I've put this in the calculator. We're going to choose the does not equal in this case. So when we hit calculate, we can see that our z is 2.02. So, and our p-value is 0.04. So we had an alpha value of 0.10. So since p is less than alpha, we're going to reject the null hypothesis. So we have rejected the null hypothesis, which was also our claim. So we're not going to change anything to support. We're going to stay at reject. There is sufficient evidence to reject the claim that 50% of all U.S. adults rarely or never fly on airplanes.